Hello and welcome to the third video on our series on Pythagoras and trigonometry. I'm Mr. Chowdhury and today we're going to be looking at trigonometric ratios. Now this is our first video on trigonometric ratios and our first video on trigonometry. However, you will need to have watched our Pythagoras videos to be able to access some of the early things that we're going to do, especially with labeling triangles. So I just suggest you go and watch those first before you come and watch this one. Now, we are going to look at labeling triangles with respect to angles. So here we've got our right angle triangle, and the first thing we need to do is draw in an angle. So there it is. I just picked that one. I could have picked the other one, but I just picked that one. Then we're going to use this angle to label this triangle. So the first thing we're going to do is label the longest side. Now the longest side in a right angled triangle is called the hypotenuse, and that is always opposite the right angle. So there is our right angle. I look directly opposite it, and that side is called the hypotenuse. The next thing we're going to do is label the other two sides with regards to this angle. Now in our Pythagoras video, we just call them A and B because with Pythagoras, it didn't matter which way round we had them because we were going to add them anyway and it wouldn't have made a difference. Whereas with trigonometry, it's very important that we label the sides with regards to this angle. So we're going to label it with regards to this angle. So this is where our angle is, and we're going to look opposite that angle and we're going to call that side the opposite. So the side opposite the angle given is called the opposite. I'll say it again. The side opposite the angle given is called the opposite. And the remaining side, the one that we haven't called anything yet, that one is called the adjacent. So I've got hypotenuse, which is the longest side of a right angle triangle, always opposite the right angle. The opposite, which is one of the shorter sides of a right angle triangle, which is always opposite the angle given, and the adjacent, which is the remaining side. So here's another one. I've moved the angle. We're going to do the exact same thing again. We're going to label the hypotenuse first. The reason we label the hypotenuse first is because we cannot apply Pythagoras and trig to non-right angle triangles. So we need to know if it's a right angle triangle first. So we always look for a hypotenuse. We always look for a right angle first. So here's our right angle. Opposite the right angle is our hypotenuse. There's our angle. Opposite the angle is now our opposite because it's always opposite the angle that we have. And then our remaining side is the adjacent. So since the angle's moved, the opposite moves. Since the angle's moved, the adjacent moves. The only side that doesn't move is the hypotenuse because the hypotenuse is always the longest side of the triangle, which is always opposite the right angle. Right? So now you're going to have a practice. I would like you to look at these triangles and label them hypotenuse, opposite, adjacent. Pause the video, have a go at that. Okay, so hopefully you've had a go at this. So let's do the first one together. There's my right angle. Opposite the right angle is my hypotenuse. There is my angle. Opposite the angle is my opposite. And the remaining side is the adjacent, the one next to the angle. Once again, there's my right angle. Opposite the right angle is my hypotenuse. Here is my angle. Opposite the angle is my opposite. The remaining one is the adjacent. Okay, so now I'm just going to give you the answers to the rest of them. So here they are. Hypotenuse is opposite the right angle. Opposite is opposite the angle. Adjacent is the one left over. Hypotenuse is opposite the right angle. Opposite is opposite the angle. Adjacent is the one left over. Now this one on the end does not have a right angle, so we cannot label it. It is not a right angle triangle, so we would not label it hypotenuse, opposite, adjacent. Remember, Pythagoras and trig are only applicable to right angle triangles. Pythagoras and trig are only applicable to right angle triangles. Right, so now that we can label some triangles, we're going to move on to the next bit in our trigonometric ratios. So what are the trigonometric ratios? Well, the trigonometric ratios are the ratios between the sides of a right angle triangle with respect to a given angle. That's why we did the labeling with respect to an angle, because the trigonometric ratios are the relationship or the ratios between the sides of a right angle triangle and an angle that we have or are given. The ratios are called sine, cosine, and tangent. We write them usually with the first three letters of each name. So sine is written S-I-N, cosine is written C-O-S, tangent is written T-A-N. So I will call sine, sine. I'll usually call cosine, cos, and I usually call tangent, tan. I will not call sine sin. It's not sin, it's sine. Right. So sine is the ratio between the opposite and the hypotenuse. Cosine is the ratio between the adjacent and the hypotenuse, and tangent is the ratio between the opposite and the adjacent. That's what they mean. Sine, opposite hypotenuse; cosine, adjacent hypotenuse; tangent, opposite adjacent. Now, a really useful mnemonic to help us remember which ratios are to do with which sides is SOH, CA, TOA. SOH, CA, TOA. So that stands for sine, opposite hypotenuse; cosine, adjacent hypotenuse; tangent, opposite adjacent. So you may be thinking, we now know what the ratios are, but how do we write them? How do we use them? Well, let's have a look. So SOH, CA, TOA will help us write these ratios. So I know that the sine ratio, sine of an angle, is the opposite divided by the hypotenuse. Cos of an angle is the adjacent divided by the hypotenuse, and tan of an angle is the opposite divided by adjacent. So if I on my calculator typed in sine of an angle, I'd get an answer, and then if I did the opposite divided by the hypotenuse, I'd get the exact same answer. Similarly, if I did cos of an angle and then I did the adjacent divided by the hypotenuse, those two answers would be the same. So applying the ratio of cos to the angle would give me the same value as dividing the adjacent by the hypotenuse. Tan of the angle would give me the same answer as doing the opposite divided by the adjacent. So let's have a look at this in practice. Let's have a look at this in action. So here I've got a right angle triangle. I've given you the sides. I've got 1, 2, and root 3. I've rounded root 3 to 1.73. I've rounded root 3 to 1.73. So the first thing I'm going to do is label my triangle. So here's my right angle. That means 2 is my hypotenuse. Here's my angle. That means 1 is my opposite. And then root 3 is my remaining answer, which is my adjacent. So there we go. I've labeled my triangle. I know that sine of an angle is equal to the opposite divided by the hypotenuse. So if you look at my diagram here, if I do 1 divided by 2, I get a half. And on my calculator, if I write in sine of 30, which is my angle, I will also get a half. Sine of 30 is equal to a half, which happens to be the opposite divided by the hypotenuse. That's the ratio. If I do my adjacent divided by my hypotenuse, if I do 1.73 divided by 2, if I do 1.73 divided by 2, I should get the same as doing cos 30. So cos 30 on a calculator gives me 0.866. And if I did root 3 divided by 2, so root 3 divided by 2, my adjacent divided by my hypotenuse, I'd get the same answer. Similarly for tan, if I did the opposite divided by the adjacent, so 1 divided by root 3, that would give me the same as tan 30, which in this case is 0.577. Now let's have a look at a different triangle. Let's have a look at the different triangle. So here's our original triangle that we worked with. Here's our second triangle that we're going to work with. What's the same and what's different? Pause the video, have a think. Okay, so if we look at each of the lengths of this triangle, what we've done to the original triangle is we've doubled each length. So instead of 2, I've got 4. Instead of 1, I've got 2. And instead of root 3, I've got 2 root 3. So I've doubled each length. What do you think is going to happen to the ratios if I double each length? Pause the video, have a think. Well, if you think that the ratios are going to change, they're not. Because the one thing that has stayed the same is this angle. And trigonometry is the relationship between the angle and the sides. And if we don't change the angle, the ratios do not change. Sine of 30 will always be a half, regardless of how big or small the triangle is. And we can have a look at this, right? So we label our triangle, and then we know that sine of the angle is opposite divided by the hypotenuse, which would be 2 divided by 4, which is a half. And then cos of an angle is the adjacent divided by the hypotenuse, which is cos of 30, which is still 0.866. And tan of our angle, which is opposite divided by the adjacent, is still 0.577. And we can see what happens if we change the size of our triangle. So let's have a look, right? So my first triangle, my second triangle, and my third triangle. The difference between my first and second one is that it's twice as big. The difference between my first and third one, that it is 10 times as big. But if we look at the calculations, that we end up doing, so in our first triangle, sine of 30, the angle is still 30, is a half, because 0.5 divided by 1 is still a half. Cos of 30 is 0.866 divided by 1, which is 0.866, just like it was in the previous one. Tan of 30 is still 0.577, because if we did 0.5 divided by 0.866, that's what we would get. And we can check the second one. The calculations are still the same. We can check the third one. The calculations are still the same. So regardless of how big or small the triangle is, the angles are what controls the ratios sine, cosine, and tangent. Now, we can use this information to check if a triangle is right angled or not, because we know what the value should be. So on my calculator, I know sine of 30 needs to be a half. So I'm going to check, is the opposite divided by the hypotenuse a half? Well, let's have a look. It is. So the opposite divided by the hypotenuse is a half, and sine of 30 is a half. So if I use the opposite and the hypotenuse, I still get a half. So I'm okay with sine of the angle. Let's check cosine of the angle. So cos of 30, we remember, was 0.866. So I'm going to do this number, 7.7942 divided by 9, and I still get 0.866. So it works for cosine as well. So far, this triangle is looking like it's a right angle triangle. We're going to check it for tan now. So tan of 30, and I do my calculation, 4.5 divided by 7.7942, and I get 0.577. And we know that's the value of tan of 30. So because sine of 30 is a half, so because the opposite divided by the hypotenuse is a half, and the adjacent divided by the hypotenuse is 0.866, we know that this triangle is right angled. Now if we got a different answer, so if we did 4.5 divided by 9 and we didn't get a half, or we did 4.5 divided by 10 and we got something else that wasn't a half, this triangle would not be right angled. And we can use the trigonometric ratios backwards to check if triangles are right angled. Now hopefully that's giving you a base understanding of what the trigonometric ratios are. You've become familiar with the layout of how to use them. So sine of theta, sine of the angle, is equal to opposite divided by hypotenuse. Cos of the angle is the adjacent divided by the hypotenuse. Tan of the angle is the opposite divided by the adjacent. And you can use that to try and practice answering some questions. So what I suggest you do is you go and watch Mr. Amoson's videos. If you're feeling super confident, you can go on Maths Watch, Corbett Maths, Dr. Frost, and practice some questions on there. Hopefully this has been helpful. You can go off and be productive, and I'll see you in the next video.